Hello everybody, welcome to Anatomy of an Attack, Defending Yourself in the Office 365 Cloud. My name is Brandon Kaler and I am a program manager in Office 365 security, focusing on mostly customer-facing security, although I do own probably more than my fair share of data center security techniques. So this session is super demo heavy. There's almost no slides. So the slides are mostly just like bullet point. Yeah, I know, right? You guys are sick of slideware? Okay, fantastic. So of course, since it is demo heavy, I have done paid my tributes to the demo gods. When you go to like Microsoft Bootcamp, they're like, when you do demos, to keep it simple, don't do many, and I've broken all those rules. So please forgive me if something fails or whatever. Today, we're going to be covering a pretty broad set of things. The agenda is to, of course, explain what I expect you to take away from the session today. I'm going to talk about attack stages. I'm going to talk about reconnaissance, initial breach, elevation of privilege, entrenchment, and exfiltration. Those are like the four kind of key, very common kill chain steps that an attacker would take against pretty much any kind of a cloud property. There's a lot in common with on-prem assets as well. But basically, for each of those attack stages, I'm going to talk about what an attacker is going to do and demo it, and then talk about what a defender should do and demo it. Right? So you kind of get the red team, blue team sort of feel about all this stuff. And then, of course, a very brief wrap-up to sort of reinforce that the takeaways were actually there. So what I want you to take away, go back to your companies, when you go back to your consulting practice and so forth, I want you to be able to, at a very high level, explain what an attacker is trying to do. How are they going to try to get my data, steal accounts, so on and so forth? What are the techniques that they're using that we see commonly? And what sort of toolkits are they going to do? And to sort of equip yourself with an attacker mindset, if you will, to sort of understand and be able to represent what the other side is going to be doing, assuming you're not a bad guy. And then, of course, the best part of that is having some strategies to defend yourself against those discrete attacks. The more that you understand your enemy, the more likely it is that you'll be able to successfully defend yourself. So the attack stages, as I sort of reviewed, are chained in a way in that they often have to occur in some kind of an order. Although that's not always the case. There are pieces of this that will feed back into other pieces. So an attacker starts with some sort of reconnaissance where they pick their target, they decide whatever it is they want to do, and then once they know that, they try to gain some sort of a toehold inside of your environment, usually by stealing some sort of an account, and then they use that account to elevate privilege, move laterally, then they figure out how to maintain access to your environment through like a remediation, like rolling a password or something, and then they try to steal data. Sometimes entrenchment's the final goal because they're not exactly sure what they want to steal, but they just want the ability to steal something in the future should that sort of come around. There are pieces of this that, like entrenchment, often leads to other breaches of other systems. If you have any sort of isolation boundaries, elevation of privilege can be used to do more recon and so forth. So it's not strictly linear, but these are the broad categories of kill chain activities that happen. Okay. So recon. So reconnaissance, as I described earlier, is what an attacker does when they're trying to decide what to do. So they ask questions like, who is my target? Is the target in Office 365? Just sort of using Office as a canonical cloud service. What data am I looking to acquire? And more importantly, what account do I need to acquire? So there's a bunch of tools that help them do this. There's not a ton of stuff that's kind of native to cloud services, so we're going off the ranch a little bit. I'm not going to demo a Microsoft-owned technology here, but this is essentially what you can imagine an attacker actually using. So the first thing I want to show you guys is an application called Maltego Teeth, and the attacker ecosystem of tooling is, man, it is overwhelming sometimes. There's a ton of stuff out there that can help an attacker figure out what's going on inside of your organization and figure out what to attack. Maltego Teeth is a graphing and visualization application specifically for data about companies, if you will, about assets inside of those companies. So it's a kind of an open source project. There's a client and a server. I have basically a community edition here of Maltego Teeth. I forgive the superfine font. Java apps don't scale well with high DPI things here. Essentially what I'm going to do here is do a little bit of basic reconnaissance on a company called SensePost. And SensePost is a company that wrote one of the hacking tools I'm going to demo here in a little bit called Mail Sniper, which is a PowerShell-based exfiltration tool in Office. So essentially what I'm doing here is connecting to a Maltego hosted server on the back end, and it's taken that URL that I fed it, sensepost.com, and basically combed through their website and run a series of analysis to extract email addresses, essentially from it. So what I get here is SensePost and a set of email addresses, and these are, this is limited to 43. It probably would have been able to extract more than that. But with just 2 clicks, I was essentially able to, actually I'm going to proceed with all of these guys here. Hopefully this will actually process that. There it goes. I was able to extract basically a non-trivial subset of the employees of SensePost. This isn't public information per se, but with a very simple tool like this, I've now saved myself hours of combing through HTML on the website to look for references to particular individuals or searching through the internet. You can do things like all these email addresses. I can search for email addresses using a search engine. So you can iterate through these. It's got social media plugins. The ones that come with the free version are things like MySpace, which aren't super relevant, but you can start to construct a picture of individuals with just a single piece of information and figure out other references to them. So you can figure out what their titles are. You can figure out what their education is. You can figure out who else that they know. And this is all super simple, and it produces a lovely graph visualization that an attacker can use to, still processing here, I could say searching the web. So it takes each of those individual addresses and searches the webs and basically returns a subset of addresses that appear to be closely correlated to them. Sometimes it's just somebody that they collaborate with. Sometimes it's like a personal address that they use. Maybe they've got a social media presence somewhere. It's still processing away here. Bing, there's all sorts of very cool bing bings happening. So what you end up with in this case is a graph. I've gone from not knowing anything about SensePost, the company and its employees, to now knowing quite a bit about quite a few of its employees. So now I'm able to sort of parse through that information. You can drill in. You can add new entities here. If I discover that there's one person that appears to be a hub for something, like let's take this individual just as an example. This is Haroon at SensePost. You can add in new connection points. You can add in their Facebook page. You can add in a computer that you think that they're using. If you find a presentation or documents online that are associated with them and so forth. So attackers think in graphs. Defenders typically think in lists. So when we are thinking about, what do I have to go fix? Well, there was this TTP and that TTP and this TTP. Attackers think like this. They think about the interconnectedness of different assets with each other, and their tools represent that mindset. So this is, of course, terrifying to think that with just a couple of clicks that your whole history might be revealed to an attacker, but that's more or less the reality of it. So another interesting thing that you can do, by the way, if you just do a search for Maltego Teeth on the internet, this tool set is basically packaged up with a Linux distribution, a freeware Linux distribution called Kali Tools. It's essentially a pen testing virtual machine, or a pen testing distribution that has pretty much all the tools that you need to do, password spraying and brute forcing. It's got all this sort of exploratory tools. It's got Nmap. It's got all the stuff that you could want just built in. So if you haven't ever played with it, it's kind of fun to just install on your local machine, spin it up, and see what all the cool kids are playing with these days. This Paterva company is the one that ships this Maltego client thing, and they've got a bunch of different versions of that. So there is this concept called Google dorking. I haven't heard of one that's similar called Bing dorking, but it's a same basic concept. Google dorking is basically using Google to find exploitable content. And so there's this thing called the Google hacking database, exploit-db.com, and it's got a bunch of kind of high-level pre-canned queries that you can go and look for. In here, what I did is I basically picked in-text database password, MySQL hostname. I have a MySQL vulnerability, and when I run that, it tells me exactly this dork allows you to search for WordPress configuration file. It contains username, password, secret keys, and other quote-unquote juicy information. Oh boy. I'm not a robot. There you go. So Google very happily returns all of the WordPress configuration files that are available on the public internet that haven't been excluded via robots.txt that include things like, hey, this particular website has a MySQL server with a, this is the username and here's the password, right? So, hooray, I've got a target. It's shocking to me how trivial this is to do. And I can guarantee you that if you're being profiled or you're the target of one of these, that an attacker will go for the cheap and easy before they do anything more complicated. So now that I've scared you with all the recon stuff, let me ask the question, what can you do to prevent someone from discovering this very sensitive information about your company? The short answer is you really can't. So you should accept that, whatever information about your company that there is to know, that it is discoverable either through social engineering, through very basic techniques like what I've just demoed for you. And the best way to protect yourself against that is to understand what your surface area is, which is to say you need to go do these things on yourself. Like if you have interns in your work at your company, give them this job. Be like, go find out what we look like on the public internet. Go find out what we look like on the dark web, even. The tools and stuff that I just showed here are trivial to get access to. There's a bunch more that you can also go investigate. The Kali Linux distribution is great, but this is the only way to really understand how you're vulnerable. You won't necessarily be able to erase yourself from the internet, but at least you'll be able to understand the likely vectors. And there'll be some things like if you turn up in a MySQL database WordPress file or whatever, that you can go ahead and take that down so you can mitigate some of these vulnerabilities directly. Okay, so that's reconnaissance. Let's talk about initial breach. So this is where a lot of times you'll hear defenders talking about this almost to the exclusion of everything else. My sense is that when it comes to techniques like phishing, where even very low success rates result in non-trivial numbers of accounts that basically serve as toeholds or initial breaches, that this is in many ways an unsolvable problem. You should do your best to understand how it happens and mitigate it to the greatest extent, just to make it manageable when it does happen. But an account breach, this initial breach sort of a thing, is the chances of it not happening to your company are super, super, super low. These techniques are trivial. Like I'm about to show you trivial stuff. All right, so initial breach stuff can happen in a wide variety of ways. Password spray is kind of the new hotness. There's two kind of passwordy, like I don't know your password and I'm going to try to figure out your password techniques. The old way is something called brute force, and essentially what that was is they would say, I want this account. And essentially what an attacker would do is try to log into that one account with a whole bunch of different passwords, right? And so, of course, we genius defenders went out and said, okay, we're going to make it so that we're going to lock out the account if there's a certain number of failed logons, or tar pit it, or require MFA conditionally, or any other number of very fancy things. So attackers have now figured out that users are terrible at picking their own passwords. They're terrible at remembering them. They get frustrated when they have to roll them all the time. And so they pick passwords like fall 2017. I guarantee that there's a user at your company today that has the password fall 2017, where the 1 and the 7 is an exclamation point or something like that. So attackers know this, and so what they'll do is they'll take a bunch of users and try to log in with one password. And that's what password spraying is. They take a single password, they spray it across a huge number of accounts. They're only getting one failed logon, and that doesn't lock out the account, but they still get some sort of an account in the long term. Other ways of stealing credentials include phishing, social engineering. Does anybody not know what that is? You guys know what that is? Okay. If you came to anatomy of an attack, you know what phishing is. So I won't be condescending explaining that. The other very common vector is password reuse, and this is something that corporations in particular have to be very aware of. I don't know about you, but the older I get, the harder it is to remember things. I functionally have 3 passwords, maybe 4 on a good day. And I sort of rank them in complexity, and you essentially reuse them. So I've got like my throwaway internet password. You have like 20 different web pages or whatever that you have to log on to, and you're like, I'm just using my BS, I don't care about this account password. And then you've got your work password, and that's a more complicated one. It has to change all the time and so forth. Users are the same way, except sometimes the password they use for Facebook or some other social media thing is exactly the same as what they use at work. And so if you read about a breach in some sort of public service and the passwords have been leaked or whatever, you should go and investigate that. You should go search that database to see if there's any of your corporate users in that database and force a password reset, because there's a good chance that they're using the same password in both places. Okay, so demo time. There is a tool that's been created by a security research company called Mail Sniper. And Mail Sniper's pretty cool. Got a VM here that I've stood up. So Mail Sniper is it's kind of a large PowerShell thing. Let me just bring it up here real quick. It is, whatever, this is like 1,500 lines of code, something like that, 3,000 lines of code. It's all implemented in PowerShell. It's a single file, and it exports maybe half a dozen or a dozen different functions, right? And it's meant to be a toolkit for basically exploiting Exchange specifically to do a wide variety of things. Figure out if a company is actually on Office 365. Figure out if a particular user is active in that particular tenancy. It works both against an Office 365 and on-prem installations, so I highly recommend you go research this, go look at it, and make sure you understand how it works and understand what the signal looks like when it's used against you. But the more insidious things that it does password spraying at scale against both OWA and EWS, Exchange Web Services. The EWS one is the kind of more insidious of the two for reasons I'll explain in a second. And it does a global mail search. So this is a super fast way to exfiltrate content from your tenancy without you really having a good idea that that's happening. Right? So you pull that stuff together and it's like one-stop shop. I can write a 10-line PowerShell script that steals an account, elevates privilege, and steals content. And all this is happening not within inside of your corporate boundaries. Right? So essentially let's see if I can get this thing to, there we go. Import the module. And I have a bunch of passwords here locally in a passwords.txt file. By the way, all these Linux distributions like Kali Linux comes with a lovely, handy set of sort of built-in common passwords and sort of default usernames. So a very common technique that you'll see with this is to take basically a out-of-the-box set of passwords. I don't have to go figure them out. I don't have to guess them. I just go find a list of common passwords and then a list of common usernames. So I actually don't know which users are in the tenancy, but they'll be like your John Smiths and your Betty Davises and the whatever names that will likely happen to be in your tenancy just because they're fairly common names. And then I do a for each here. So my password file has a certain number of passwords in it. I think there's like 8 of them in here, something like that. And then I essentially go through each user or each password and try to log into the set of users that I have targeted here. And right now it's going to do this over EWS. Expand this a little bit. So it's trying Exchange 2010. The version number doesn't matter too much. One thing that you'll notice here is the script itself doesn't doesn't have any dependencies. So they've been very clever. Normally to interact with Exchange interfaces, you have to have client code, like a local DLL, like EWS. You can go get a free EWS DLL, put on your local machine, and it's got all the object models you need to connect to Exchange Web Services. This doesn't require that. They've actually taken and serialized the contents of that DLL right into the PowerShell script, and so they import it just from a gigantic, encoded string and get all the features and functionality that you need. So it's very, very lightweight. An attacker doesn't have to do much other than hit F5. So what the script does, it has a few successes here, and it actually outputs it. I've written it to output all this stuff to a file. So each of these basically have a username and a password. So this user, Karima, just so happened to have this Shelby .pass1 password included in it. So I wrote it out. So now I've got my initial breach. It was that easy. Literally 4 lines of code of super complicated for each loop and a downloaded Mail Sniper thing. And I now have my toe in the door. The other thing that I can do here, okay, so that's the attack part. I don't think I dumped the, yes, I do that later. Okay. Going backward? Okay. So that's it. Like, it's that easy. Rinse, wash, repeat, and with guest usernames, different usernames, or whatever, until I finally get a username, password, credential pair that allows me to log into this particular tenancy. Hooray, victory. Okay, so how do I defend against this? So for all this stuff, my motto is the best defense is a good offense. So doing this against your tenancy is the best way to validate whether or not you're vulnerable to it. So one of the things you do is download Mail Sniper and dump in a list of your users and find some bad passwords and just run this against your tenancy. If it actually finds known bad passwords, you have the ability to reset that password. So an attacker's not going to want to do that. You now understand the vulnerability and can fix it. Other things include multi-factor authentication. That reduces the risk of losing the password, the plaintext password, in that it now requires the attacker to figure out how to either fake, replace, or get access to a multi-factor authentication token associated with that particular user's account. That is much more difficult. That is a very effective mitigation against these initial breach things. The other thing, I mentioned this earlier, EWS is considered a legacy protocol, and it is somewhat challenging for it to support modern auth technologies that have a very usable MFA experience. In most cases, EWS wants to use older clients, and they typically want to use older auth methods like basic authentication. And while basic auth can support multi-factor authentication, it's usually done with something like an application password. So a special password that's basically just a second password that your app owns to be able to authenticate. It's usually really complicated for users and they hate it. And so what you'll find is a lot of Exchange administrators will just say, you know what, if you have an ancient client like an iPhone 5 native mail client or something like that that's going to connect to EWS, you just make an exception to allow EWS to bypass your MFA policy. Allow basic auth, here you go, I don't come on in. So attackers know that and they exploit that for their own gain. Failed logon policies, one of the downsides to having an aggressive failed logon policy is when you get even a slightly aggressive attacker password spraying your tenancy, they'll lock out your accounts in mass, especially if you have something like a ADFS thing where you have hybrid like on-prem and in the cloud authentication. So you have to be very careful about how you tune that. I've seen companies that have set their failed logon lockouts to 5 failed logons and disabled 20,000 accounts all to go, just because an attacker ran something like Mail Sniper with 6 passwords. So it hit that 6th failed logon and all their accounts got locked out. And they're like, what?
So some of us are screwed then. Like we have compliance that says 3.
Right, exactly. Exactly. Push back. I mean, all you can do is say, look, this is easy to repro. If you want to distribute it down and out of yourself, this stuff, you can leave this policy in place, but it will happen if your company ever gets targeted. So the other piece of this is phishing protections. There was a ton of phishing content at this conference. Hopefully you got to consume some of it. I won't go over too much of it here today, but you know, it is out there. One thing I wanted to show you guys is that Microsoft has taken this attack yourself thing to heart, and we are working on a platform called Threat Finder. We just announced it at the conference this week, and it is an attempt to help customers connect the dots between different threat vectors, the people in your company that are most vulnerable to being attacked, and being able to actually simulate those attacks. And you can think of it like this experience will collect passive signals from your tenancy. How much external mail do you get? How many links are in that mail? How many of your users actually click that stuff? That's non-deterministic, right? It's just data, you collect it, you get a sense of, okay, this person, maybe, maybe not. There's a sales guy, they work with external people a lot, probably okay. But now you can take and actually perform an attack against that person in a safe way to see if they're really vulnerable to phishing. Do they really understand how to look for a phishing email? Have they taken the training, the corporate mandated training that you guys have made them go to heart? So this allows you to essentially do all that stuff natively in Office 365 to prove to your leadership that all the threats that you have been talking about and telling them they need to invest in, that they need to get over their problem with MFA and actually turn it on, you can prove it to them with this. So the password spray attack that I just demoed, you can also do in this platform. So we're going to call this Ignite Demo for Anatomy. And I'm going to search for some folks here. I'm going to password spray, actually Karima, who I know I have the password for. And let's also search for Stuart Clanker and Pedro Nino. Bam. So I'm going to attack these three cats. And the password that I'm going to pick is that password that I just stole. I think I still have it open here. Here we go. Shelby Pass 1. Bam. So I'm going to do a password spray attack against these three users. And the attack's been scheduled. And hopefully it's running. I'm gonna run this a few times here. I think this is a different one. Hold on. Ha! This is the one. Okay, so it's done. So it targeted 3 users, and it had 1 user that was actually compromised. So if you can imagine doing this, you now have proof that this person has a bad password inside your organization. There'll be a little button here that says reset this person's password. Send them an email and say, please don't pick crappy passwords in the future. You can now do a bunch of other things associated with this. We're framing this in the same context as the secure score. Has anybody here heard of the secure score? So many people, it makes me happy. Okay, great. So this is meant to fit into that same framework that you use to justify all the awesome progress that you're making on all the other cloud-based security features that you've driven and adopted and so forth that you're getting credit for in the secure score. This will play right into that. So it'll make your score go up, essentially, which, we all like taking credit for doing good things. Okay, so that's that. So that's defense for initial breach. Okay, elevation of privilege. This is also surprisingly easy for most organizations. One of the first things that an attacker will do once they get that initial toehold breach, they breach that single account, is dump your directory. All your users have access to your entire directory. It's trivial for an attacker to do this as any user, and it basically gives them, here's the playing field. These are all the potential accounts that I can breach inside of this organization. I'll show you how easy it is to do that here in 1 second. The next thing that they do is they try to find your administrators, which is also surprisingly easy to do. And then once they have those 2 pieces of information, they just password spray till they win, or they fish until they win. Once they know these are the 20 users or 100 users or 1,200 users that have some sort of administrative privilege inside of your tenancy, those are the target. Because once they have administrative privilege, they can do pretty much anything that they want to be able to do. All right, so demo time again. So I have a little elevation of privilege thing here, and I'm going to import Mail Sniper again. So the first thing that I'm going to do here is to use a very simple Azure Active Directory PowerShell plugin as a user here to dump all of the users that are a company administrator or Exchange service administrator. So the first thing you do is install Azure Active Directory, and you get an admin credential, which I'm going to have to put in here in a second. You can also do this with a non-admin credential, but I'm going to use an admin, and grab the password. Don't store admin passwords in a notepad called meow.txt on your local desktop. I'm sure you guys already knew that, but I was just trying to dodge the demo gods, I promise you. Okay, so it actually goes and it gets all that stuff, and it dumps those admin users to a local file called adminusers.csv. And what I essentially get here is a lovely text file that I can parse. It gives me their GUID, their signed licenses, it tells me their addresses, first name, last name, their UPN, so on and so forth, as well as the actual role. It tells me what their password enforcement model is, so I know if they have MFA in it. It tells me all manner of very interesting things. For example, like where they are and so forth. It's all super valuable if you're trying to figure out who I need to go after inside of this organization. So once I do that, I can then invoke password spray using some password in there and dump that out to user. The production of a basically the global address list is again a very similar sort of a thing. I won't run it. It takes quite a while to run, but it's just get-global address list with the username, password. You set the global address list.txt, the output file, and what it produces is this. This is literally just a nice, lovely UPN file. You can take this file and literally feed it right back into that password spray thing. It's trivial. You can password spray all the users after basically a single turnaround or single iteration. The script essentially goes through every user and reconstructs it so that it produces a very long list of users, and then it will very handily dedupe them, so you don't have any duplicates in your list of master users. So it's got that going for it, which is nice. Okay, so that's elevation of privilege. Again, fairly straightforward to do, especially if you have administrators or a lot of administrators inside of your organization. So this brings us to the defense of this. So MFA, this is crucial. If you've looked at the secure score, the #1 recommendation with 50 points in the secure score is enable MFA for your global admins. If you aren't doing that, you are losing, or you will lose very, very, very soon. So it is crucial, critical. I'm trying to think of some more like bigger words to describe this, but it's super important that you enable MFA, especially for your administrative accounts. Least privilege is another really great concept to leverage here, and what least privilege says is that users only get the minimum amount of privilege that they need to do their job. And I know Microsoft and all these other cloud companies have not, we could do more to simplify role-based access control and how you can refine this set of privileges. We have a lot of work that's in the pipeline to actually do that, but there are a lot of roles that are available to you today. Global admin, you should have very few users in global admin. And to be honest, they shouldn't even have standing global admin. Second thing you do is just-in-time access. There is a platform called PIM, Privileged Identity Management, and Azure Active Directory that will allow your administrative users to self-elevate. They actually have just released an approval feature in that to whatever administrative privileges that they need. And so that then turns this elevation of privilege into a timing attack, which is much harder, which is to say an attacker has to figure out who has the elevation right now in order to leverage that account to be able to do whatever it is they need to do. So it's just it's a nice way to make sure that in the middle of the night when these guys in Eastern Europe or whatever are trying to log in with your administrative accounts, that they won't just already have the privilege assigned to it. Alt accounts is another good protection. The account that people use every day to log into their email should be different than the account that they use to administer your service. So if they're creating users and setting passwords and stuff, you can just create them an alternate account, admin dash their username, at domain.com, and say, look, if you're gonna do any administration, do it from a corp hosted machine that's been secured, that you know is patched, that has AV enabled on it, that has a firewall, and make sure it has MFA on that alt account, make sure it's only elevated just in time, and it protects all that administrative privilege. All right, so monitoring administrative activity. Your main protection here, your main defense is to make sure that you know where to get data about who's doing what sorts of administrative things in your tenancy. So the Protection Center in Office 365 has a feature called the Audit Log Search. And this is kind of the main way to consume audit data. There's a bunch of dependencies associated with this. So if you're on Office 365, let me ask, how many people are either on or thinking about getting on Office 365? Almost everybody in this room. Hooray, thank you for buying our service. So great, if you're on Office 365, go to protection.office.com today and go to this page and enable auditing. So it's not enabled by default, so this is like an extra step that you have to do. We are working to make it enabled by default, but as it turns out, there's a lot of you, and we don't have all the computers in the world yet. So enabling auditing is how you make sure that we're collecting audit data, including all of this administrative activity stuff, and it is a must-do. It's like the number 3 control in the secure score. It's worth 20 points to go turn this on. In addition to enabling the audit pipeline, you should also enable mailbox auditing. So by default, Exchange mailboxes only have non-owner access audited, which is to say delegates, people who are not you that interact with your mailbox, those audit events will flow. But owner access, the user that actually owns that mailbox, their logons and sending mail, deleting mail, doing all this stuff, not necessarily audited. So if you want to know if somebody's added a mail forwarding rule or any of that other stuff, you have to enable auditing on a particular mailbox. So there's a PowerShell script. It's like a single line. You basically enable it. It's like set mailbox auditing, blah, blah, blah. We've created a script that I'll point you guys to at the end of this that you run. It takes however many users you have. It takes a second each. And then all that data will flow into this interface. So this is the web version of this interface. There is a PowerShell commandlet called Search Unified Audit Log that does the exact same thing. And you can think about this as how you do scoped searches against your audit data, right? So your audit data basically represents all user interactions with the service, and this is how you figure out and recreate or reproduce what actually happened. It's a bunch of fancy queries here where you can look at by categories like file and page activities, folder activities. These are all SharePoint-y things, site administration, Exchange mailbox activities, Sway activities, user admin activities, and so forth. So you can filter it. I just did a global search here, and it returned essentially a bunch of logons for this. This is all me getting ready for this particular thing. When you open these, it'll give you full details. So this is the IP address that I logged on to this particular mailbox from, and it will tell you other sorts of things. Let's see, there's my SID, my mailbox GUID, what I did, the organization I logged on to, and so forth. So this is how you're going to do your administrative monitoring for that. There's another version of this that I'll show you guys in a little while. Okay, so entrenchment. This is the, I don't want to say the scary part. This is the part that scares me anyway. There's been a resurgence, if you will, in attacker sophistication in this particular bucket. Initial breaches are, there's a limited number of techniques to be able to do that. Entrenchment gets more and more clever, and entrenchment is a way for an attacker to defeat your remediations. An account has a certain set of things that you can do to it. You can reset it, you can do things like disable it, make a new one, so on and so forth. Entrenchment is how an attacker bypasses all that stuff and maintains their access to your environment, essentially by operationalizing initial breach and elevation of privilege right out of the box. So some of the things that they'll do here is they'll create alt accounts. If you are not monitoring your user base, which is to say you're monitoring especially administrative accounts, for accounts that somebody didn't approve and create, you are giving your attackers a place to hide, because that is a very common thing. The second thing is impersonation. This is a very Exchange-specific thing. You can think about it like, Exchange out of the box doesn't allow an administrator to interact with user mailboxes, right? And this is a great feature. So your Exchange admin can't just log into your CEO's mailbox. He has to either get delegate permissions or impersonation. And so it's a auditable event, which means it's detectable, and which means that you can implement some kind of slightly delayed protection against it. I'll show you how easy it is to do impersonation. Impersonation is it's essentially a privilege that allows the owner of that impersonation privilege to act as if they were the owner of the mailbox, as if they have all send as and operate on. It's as if they're the owner of the mailbox. It's not a delegated, like this user has delegate permissions to send as to this particular mailbox. It's like they are the user almost. It's like the God token for Exchange. This is very dangerous. It was implemented for services like BlackBerry Enterprise Services. How many of you have or currently do run BES? No? Just a handful of you? Okay. Congratulations. All right. So, yeah. So it's not many people run it that much anymore, but impersonation persists, if you will. Delegate permissions are an excellent way. Most people don't have any visibility into their own delegate permissions, especially executives who almost always have some sort of delegate permissions on their mailbox. It's somewhat difficult to discover for end users, and so as security admins, you should be monitoring that for them. So the demo here is probably the juiciest part of this whole thing. So I have a bunch of different techniques, and I'll try to obviously go slow here, but I'll try to walk through it one by one. Okay, so the first thing I'm going to do here is get an administrative credential and set who I'm going to be going after. So I'm basically going to be pwning, I think, Brandon. That guy does not have his stuff together. So I'm just logging in here, and I'm going to log into Exchange Remote PowerShell. So this is establishing a connection, and it's going to import all the commandlets that are available in that. Because I'm logging in with an administrative account, it also has access to all the administrative sorts of things. So this is the before. What I'm going to do is show you the current state of the nation on inbox rules for Brandon, mailbox permissions, mailbox folder permissions, whether the mailbox has been set to forward, like mailbox forwarding, any management role assignments, and any rules and forms. And so those are two very distinct things that have been very difficult, challenging. This hopefully will fail for some of these things. Oh, no, it did show me them. Okay. All right, fantastic. So when you go through this, it shows you a bunch of data about this particular user. So these are the access rights that are available. You can see there's quite a few on this particular mailbox, but these all look legit, right? This is self and administrative accounts and so on and so forth. So at the moment, at least, nothing super illicit. These are the mailbox permissions that I have assigned. So at this point, it's just me. This is not forwarding any mail. There is no management roles being assigned, at least not at the moment. And interestingly, so Ruler it's like Mail Sniper. It is a Google Go language authored pen test tool authored by this guy named Etienne, a pen tester who works for a company called SensePost. And it's a fantastic tool, and essentially it is a tool that allows an attacker to maintain access to an environment by leveraging a couple of currently patched vulnerabilities in Outlook. But how many of you are on the latest and greatest version of Outlook as of like 2 weeks ago? Like, not many of you, right? A lot of us still running like 2013 or 2010 or older versions of Outlook, right? It's really hard to keep up to date with this kind of stuff. This vulnerability is still essentially out there, and it's particularly insidious. So this tool, this ruler tool, does all the things that I talked about earlier. It allows you to do recon and figure out if somebody's actually on a tenancy, if their account's active, and so forth. But what it can do is create mailbox rules that will essentially execute code remotely. So the rules, we'll go through this in a second, but the rules injection leverages a type of rule that's essentially hidden in newer versions, but you can create a mailbox rule to launch an application. That's one of the action conditions that you can set on a mailbox rule. If this particular thing happens, this mail comes in with this subject line or it comes to this particular person or whatever, then I want you to launch this application. Well, as it turns out, that particular launch application thing will also launch WebDAV hosted applications, which is to say remote applications. And so essentially what this would do is this guy would breach a particular mailbox, create a mail forwarding rule that said, if I get a mail from such and such an address or with such and such a format, execute this WebDAV hosted basically piece of malware, install PowerShell Empire on my local machine, essentially. So it's essentially a rule that most of the time a user's not going to know is there, and all the attacker has to do is just send that person an email to trigger the rule and install the PowerShell thing locally, right? So even if you reset their password, you require MFA, all you have to do, send the guy an email. And it'll reinstall PowerShell Empire locally or some kind of malware that they want to do. And at that point, they can run some sort of a cred dumper locally to basically re-steal the new password and maintain their persistence. The other one is something called forms exploit. All content in a mailbox today, when it's rendered in the client, takes a template, basically a formed template, to figure out what it looks like. It's all in the back end. It looks like just a database of tables with content in it, columns and folders and rows and stuff. When you render it in Outlook, Outlook has a formatting mechanism, this templating thing, that actually takes that content and lays it out in the way that you expect, to and from and all that other stuff. So those forms are customizable, and it's not super common, but it is possible for an organization to be like, I want my own custom form. I send it out every week, like the where are we going to go to lunch form. And so they send this custom form out to people, and it's got like little voting buttons in it or whatever. But as it turns out, those forms can have VB in them, VB script, including the execution of arbitrary code in there. All the demos I'm about to show you are all, I just execute calc.exe, but you can imagine an attacker basically just injecting PowerShell Empire encoded in a giant string so that when that form is invoked, it'll just execute that code arbitrarily. And it falls outside of the constraints of the normal sandbox, like the macros sandbox. So even if you have macros disabled, the form stuff will still launch. Right? Okay, so in this particular case, I'm showing you that there's actually already a malicious rule in here. I didn't clean this up from last night, but there are no forms that are in here. So that's the kind of clean version of this. All these techniques I'm about to show you are viable. An attacker can execute them today, and I've seen all of them in the wild sometime in the last few months. So these are what I call for realsies. So first thing I'm going to do here is I'm going to set up some illicit mail forwarding rules. These are super simple and can be super powerful, especially for stealing money from your company. So essentially, what an attacker does here is, when they own the account, they just create a mail forwarding rule to say all the content that has a certain whatever, I want you to send it to this other mailbox, right? So a very common pattern that we see is account payables clerk or something having their mailbox breached. They create a mail forwarding rule to forward all mail that have the word invoice in them out to a Yahoo account or a Gmail account or something like that. An attacker will just monitor that activity, be like, aha, this particular person gets paid second Tuesday of every month. And what I can do is take that invoice and edit it, put my bank routing number in it, and then send it to the downstream customer. And then when that customer pays, and they're like, oh, weird, new bank routing number, it comes from that account payables clerk, so it must be legit, then they will happily pay the attacker. Here you go. Here's my $25,000 payment or whatever. It all started with a stupid forwarding rule, right? Trivial to make that, right? That was like, I don't even own that mailbox. I have Exchange admin privileges, and I can create all these things with a single line of code. So there is a forward to, forward as attachment to, and redirect to. Those are all, legit. This is a mailbox permission thing here. I don't know if this will actually work. Yes, it did. This is adding a mailbox folder permission. So mailbox permission basically gives me full access, so I can send ads to that user. Folder permissions gives me the ability to edit content in their mailbox, which is to say read it from wherever. This is actually setting an attribute on the mailbox itself, saying all content sent to this. It's not even a rule, not discoverable as a rule. It's just an attribute on the mailbox. All content will get forwarded out to another person as if they mirrored that mailbox with an external entity. Well, by the way, there are mitigations for some of this. So I know I'm being dramatic to some extent, but there's always an answer for this stuff. So the last thing I'm going to do here is assign impersonation. So I'm granting Karima application impersonation rights. And the way that this works is basically this, by the way, straight up stolen from that mail sniper script, creates a random number so that the application assignment deduces itself from previous uses. So you don't get a collision, essentially, of the role name. And then you assign the role. It's single line. New management role assignment. Here's the assignment name I want to give it. I'm going to give them the role application impersonation, and this is the user, and then boom, done. Okay, so I wanted to just very quickly show you guys how easy it is to do this custom form thing. So I've got an older version. This is Outlook 2013, so this is still vulnerable. If I click Design a Form, hopefully this will work. Say about half the time I get some guff. This is the function I'm going to be running. calc.exe. All right, so this isn't not a good, super great sign. Close the program. Don't do any of that stuff, Outlook. All right, okay, closed. I'm going to relaunch Outlook here. Once more into the breach. I got an alert. Okay, so I click Design a Form, and what I'm going to do is design a new message form. Click Open. So this looks just like a regular mail message, but you'll note here there's this little button that says View Code. So when I click that, it gives me a little script editor. I'm going to paste that in there, and then I'm going to close that. And then I'm going to publish this form as, I'm going to put it in the inbox. It's not super common. I'm going to call it double pew pew. Later on, we'll inject another rule called pew. So we're going to call this double pew pew. All right, it's now published. Don't want to save my changes. So now when I go back in here and I look in inbox, I see double pew pew. So I know that it's in there. So now, if I'm the attacker, this is the manual way. They're not doing it this way. They're using Ruler, which is like a two-step thing to do this remotely. I would then take that form, I would export it, pull it off their particular client, import it into a remote client, and then send them a message with this form type. So the way that that works, they just say New Item. There's now a drop down here called Custom Forms, and there's my double pew pew, right? So you can imagine this as like lunch appointments or something, way less suspicious than that. So when I open that, boom, there's Calculator. Calculator, also known as PowerShell Empire or some other remote access toolkit that's now just been installed on my local machine. So when that user gets that message and they open it, that's what they see right away. Okay. So now I'm going to add in a calc trigger on invoice. I'm going to name it malicious rule 2. And I'm going to have a subject line of invoice for review and a body that says, can you review this? And then I'm going to have Ruler send this right away. So I click that. I hit F8. It's going to auto send mail here. So this is very nice. They actually make it so that you inject the rule, and then it will send the message that will actually trigger the rule. So it's like a bam, bam, a double, double. Although you can just inject the rule and actually trigger it later if you like. And hopefully what we'll see here is a new message come in. This says, can you review this? Delete that guy there. Okay, message sent, your shell should trigger shortly. Boom. So you see calc pop up there? I promised I didn't launch calc. That was the message actually being sent. Here's the particularly insidious part of that. That rule is in that user's mailbox, but you'll note that that mail isn't actually in that user's inbox. The rule launches it and then deletes the message. So the user doesn't have to do anything other than just have it open. And so, when you're talking to a user, they're like, I didn't do anything. It's okay. We understand these guys are really super clever, right? Okay, so the other half of this forms thing here is execute ruler, and I'm going to add a pew pew. And in this particular case, you can actually put the malicious code that you want to run in line, but you can also do it from a command. And you can see that it just launched again. I now have so many. But a very similar thing, there should be another form that's in here, probably in the mailbox, inbox. Double pew, it's called hidden. So it created one called pew pew, and then it set the attribute on the particular form as hidden, so you can't see that in here. So even if you knew that this particular user was infected, you'd be like, what is that? That's weird. Maybe Microsoft had some genius implementation where they created a magical hidden form that does magical things. Okay, so this is essentially the same kind of proof point script that I ran beforehand. I executed, 5 lines of code, 6 lines of code to just completely entrench myself in this particular user's mailbox. And you can see now that I've got 2 malicious rules and 2 forms and all manner of shenanigans. So I have as much access to things as I could possibly want. I have permissions and delegate access and all that kind of stuff. All right. So how do you defend against that? So monitoring is the key, not surprisingly. If you're aware of all this stuff being possible, then you have some hope of being able to find it down the road. So one thing that you can do for all of the mail forwarding rule attacks, there's a kind of one global mitigation for this that's in place right now. It's not super elegant, but it works. It's essentially to create a transport rule that basically blocks forwarding to external mail addresses. And you can create a whitelist exception for that. What's nice about that is if a user gets entrenchment on a particular mailbox, when it tries to forward, the user will get an NDR. If you like do other things than this transport rule thing, you can do that. Like there's attributes on a mailbox and other sorts of mitigations. This transport rule actually makes it visible to the end user, which helps you scale. So the user's like, I didn't forward that mail, where'd that come from? So it gives you some hope of actually detecting it. And the secure score experience actually has this as a control in it. See if it might be implemented. Yeah, I think it is. So it's going to be over here. Sorry, I had to relog on. My token. Oh, there it goes. Enable client forwarding rules. Okay, so there's this lovely remediation here. Enable client forwarding rules block. Tells you exactly what you're about to change. It gives you some links here to go read more about what this does. And essentially, you click apply, and it will apply that particular thing. It's like a 2-click mitigation. So you don't have to be a transport rules genius. You just have to know that attackers are using mail forwarding rules to steal your content today and entrench themselves. And this is one way to protect against it. Other things that you can monitor, other than the audit log search, things like creating new mail forwarding rules and saying those attributes do turn up in the audit log, so you can monitor for those particular things. There's also a premium feature that's available for Office 365, part of the E5 SKU called Cloud App Security. MCAS, Microsoft Cloud App Security. Office Cloud App Security, sorry. The marketing guy's yelling at me. you can do a bunch of different things with this, but one of my favorite things is you can do an investigate activity log. Here what I've done is just said anytime add impersonation role assignment happens, I want that to be a thing. And you can see last night when I did this, I added the application impersonation rule for this particular thing, and it's got all the details that I need to know about this. So this can become an alert, which can, I will then be notified if somebody's using it illicitly. So there are things that you can do. The other thing that you can do for the rules and the forms, which are much more difficult to detect. So the gap with the rules is that when you say get mailbox rules from the commandlet, it doesn't actually tell you what's in the payload. It just tells you the conditions, like this particular rule will trigger when such and such happens. It doesn't tell you what it's supposed to do, especially with application execution. And the form stuff is, there's basically no way to do it at scale to be able to retrieve all that. So we wrote a script, and that script is, I'll show you guys. Let me get to this guy. So my team has a GitHub, which I recommend you go check out. Let me see if I can find it. Here we go. O365 investigation tooling. And basically we have a bunch of PowerShell scripts in here that help you do things like dump delegates and forwarding rules and remediate breached accounts and basically set up activity API, data consumption, enable mailbox auditing, that script that I was talking about earlier. This is a very short script, get mailbox, and then just enable audit logging. One of the things we just put in here a few days ago is this get all tenant rules and forms. And essentially what this will do is connect to your tenancy via EWS. It will pull and decode the contents of the mail forwarding rules and the forms that are inside your tenancy and return it to you in a CSV so that you can use it for an investigation. We're working on better mitigations. If you're on the latest and greatest versions of Outlook, both the rules and the forms mitigations are enabled by default, like an attacker has to work harder to disable them and so forth. But this, at the moment, this is the best way that you have to discover that, that you actually have these vulnerabilities. And so I will run that for you guys here. I have it on the local machine, get all tenant rules and forms. It's gonna prompt me for my username and password again. Bam. And super complicated password. Bam. So the downside to this particular mitigation is in order for me to connect to all of the mailboxes inside of the tenant, I have to use application impersonation. So not a great story around all that. Obviously there's a fair amount of, actually this is launching because it's already in the RDP or already in the remote PowerShell session. It's granting itself impersonation rights. After it does that, it has to, the script sleeps for 30 seconds because it takes a minute for application impersonation rights to propagate throughout the rest of the domain. But then once it does that, it's able to freely bind over EWS to all the mailboxes, get the mail forwarding rules, all that content from the mailbox and all the forms, and then basically put it in a local variable and then dump it out to a text file. Doesn't scale super great, so if you've got a 250,000 seat company, might take a week for this thing to run, but you'll get there eventually. The advantage of doing this is it actually gives you a couple of nice local text files here. So this is what the rules export looks like, and essentially what you get here is this. You can actually see what the payload is of that particular rule. So if you see something there, like an executable that says, PowerShell Empire or one of those other remote access toolkits, then you know that there's something illicit going on. It's difficult to discern between good rules and, if you're a productive Outlook user, your users will have many, 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 many rules. So this is like a, how do I find the needle in the haystack kind of a situation. The only way you can do that is to actually look at the executable that's being triggered as part of that rule. The forms are much less common, but they're also somewhat difficult to determine. In this particular case, there is these two form descriptions. Be somewhat careful. If it says IPM.note. something funny. It's probably not a legitimate thing, although attackers sometimes can, hide stuff. We still have to do some work to try to filter out like good forms in there. But this is kind of your best case. And this is a 50-seat tenancy, and it found, this many custom forms in there. And this is with us actually, putting in a lot of forms in there. So there is hope, if you will. Okay. Where are we at now? Back to here. Okay. So exfiltration. From an attacker's perspective, once they have an account, they have access. And that's pretty much all they need to be able to do some sort of exfiltration. I've most commonly seen it as a quote-unquote smash and grab, which is to say they will get tiny bits and bytes here while they're trying to figure out what they want to steal. And then when they're ready to steal it, it's like they get everything in this huge, you're like, wow, how this is, it's not like every day they just log in at 8 a.m. and they start downloading and then, they log off at 5. They find a way to get the exfiltration to scale, and they wait until they're ready, and then they get everything all at once. And so it's important that you have things in place to make sure that you can detect them, at least as best as you can. So the demo for this is with Mail Sniper. All right, this is done. By the way, my script does clean up the application impersonation, so it disables it, so that account doesn't have persistence. All right, I'm going to close that guy, and we're going to bring up this. So exfiltration. Again, this always blows me away that it's like the attacker imports the module, they import the search strings that they want to look for. In this case, they're looking for password and creds. They're looking for, special projects and whatever. Like they'll have some agenda in here. We've seen something as basic as star.star for content, so basically match any content that you'll see in there. And this function, invoke global mail search, basically you tell it what account you want to use to do the impersonation, what the Exchange host name is and the admin username. You can feed it the password if you don't want to have to type it in. You tell it how many mails you want to collect per user, the terms that you want to do, and what you want the output list to be. So just single line, you hit F8, and it connects over EWS. It establishes a remote PowerShell session. At the moment, the only way to assign application impersonation is over remote PowerShell, so that is an advantage. It's a simpler way to detect it. So if you're collecting the remote PowerShell logs, you can do your detection about application impersonation at that point. So I don't think there's an EWS or MAPI way to do that. So all the management functionality is mostly centered on remote PowerShell. So once you do that, it basically, using the application impersonation account, will connect to each user's mailbox in kind and perform a mail search on that particular mailbox. At the moment, there's not a lot of great telemetry about global mail searches. So detecting that somebody's performed a mail search in this particular way, it's not obvious. And because of the way application impersonation works, what you'll see is a log on to each mailbox by that particular user versus by the application impersonation rights. No, it doesn't. That's the thing, application impersonation, it looks just like the user logged on. So it might be weird to be like, every single user logged on in the same 5 minutes in my tenancy. That's a little unusual, but it is what it is. So we are working on making that telemetry better. Basically it goes through each of the mailboxes. This does take a little bit of time. I'll show you what the output of this is. I'm outputting all this stuff to a file called search matches, and essentially what it does is dumps all the content of that mailbox with all the content, like who it's to, who it's from, and so forth, to a very handy CSV to do all this stuff. The commandlet actually allows you to download attachments as well. So if you send mail, if you send documents around for editing and stuff, just be aware you're not talking about just mail content here. You're talking about document content that's also included in the search results. and the script will very handily put them in a nice folder locally, create a folder, stick them in there for you, so you can be organized about your hacking. So that's how easy it is to exfiltrate content at scale from any kind of Exchange tenancy. It's literally a one-liner, if you will. All right, it's done. So that was, whatever, 50 some odd things. And you get a sender, receive by subject and body for that. Okay, defending yourself. So there's a couple of things that you can do here. DRM, IRM, whatever you want to call it, is actually remarkably effective at making sure that this content is not super consumable downstream. So if you've got sensitive content and you've got reasonable classification rules associated with your content, when they steal it, they won't be able to read it because they don't have access to the decryption key. At least so long as you've managed to eject them whole body out of the account, which is to say you've caught all the entrenchment techniques. You can do some monitoring things for things like cross-mailbox search queries. You can monitor for gateway mechanisms like impersonation. As I said earlier, the Cloud App Security does have the ability to set up alerts, and you can create, oh boy, I don't want to do that. Oh, it's control policy, there we go. Control policies. So it's got a couple of built-in things which are nice. It'll basically monitor all the right activity as it's flowing through your pipeline. This automatically consumes all the audit data directly into this platform and sort of does these detections by itself. Mass download by single user from SharePoint sites is one of the policies that you can do. So no need for you to do much other than sort of turn it on and make sure you actually answer the call when it comes. Okay, wrap up. Look at this. I'm gonna be so early, you guys are gonna have so much time for questions. You guys get extra double points, by the way, for hanging out all the way to the very end of this conference. I'm sure you're all exhausted, and I definitely appreciate you coming. Hopefully you're gonna walk away with some sense that the data access to what's going on inside your tenancy is key. You'll all go out and make sure your audit feed is enabled for your Office 365 tenancies. You need to understand that your risk is spread across hybrid and multi-cloud. So even when you're in the cloud, your on-prem infrastructure is a vector. All those entrenchment techniques, those rules and forms, that is a remote code execution on your clients. That's not quote unquote in the cloud. All the cloud is doing is helpfully syncing those exfiltration techniques down to all of your clients. But you have to make sure that you've got good coverage, good AV, good patch, good firewalls and so forth to mitigate some of the risk associated with that. In the end, these cloud service, when you adopt these, you still have to know what your security exposure is. So you have to plan for this stuff, you need to practice, you need to attack yourself, you need to implement controls, you need to implement monitoring, make sure you have robust alerting and escalation and so forth, and you have to test yourself over and over and over and over again. Never goes away. All right, I will now take questions. I think there's a few enough of you, if you want, you can just come up and we'll just call this here. As you guys go home, enjoy your flights home. Thank you for attending Ignite, and thanks for attending my talk.